So our second skill in our first learning unit here on Essentials of Chemistry deals with the concept of unit conversion. And this video is going to be a little bit on the longer side to kind of go through and introduce this whole skill. But this is such a critical skill for understanding how to do so much of the computational work that we're going to do here in chemistry. So again, I've got highlighted here, it is probably one of the most important skills that we're going to learn here in general chemistry. So I really want to make sure to take some time and go through how to do it and just have it be a skill that we continue to practice and see as we move throughout the course. So the first thing to highlight here is when we talk about quantities in chemistry, they really are going to have three parts to them. There's going to be a value. That's the numerical part of the quantity. So for example, 1.75. But 1.75 is kind of meaningless without other pieces of information. The next piece of information that comes after the value is the unit. So that adds some description to the value. For example, 1.75 pounds. Now, even at that might not be a full description of what that chemical quantity is. So then we're going to have a qualifier. And again, that's a descriptive piece that shows who owns that value and unit. So for example, 1.75 pounds of flour. And so having those three pieces and continuing to keep track of those pieces as we go through problems is going to become really important. And I promise you, if you keep your units, and I know it's laborious to write them, but it's hard to not get the right answer if you always make sure you have the right chemical quantities in your calculations. All right, so this concept of unit conversion, unit meaning unit of one, it starts out with one quantity, and by using these values of one, we're basically going to be changing the units of the quantity, which also will change the numerical value, but we're maintaining equality. We're not changing what we have, we're just changing the units that it's in. And so when we think about doing unit conversion and really changing units, these unit conversion pieces come in a few flavors, some that you're going to have to know and memorize, and some that will be provided for you. So the first set that I'm going to highlight are what we call prefix conversions. So these involve units of usually base 10, 100, 1000. These are our metric conversions. So on the next slide, I'm going to show you a table of these values. And again, the bolded ones are going to be the ones that you need to know. The next set of unit conversions we'll talk about are English to metric conversions. These are kind of converting between some things that are unique, not usually based on a factor of 10. These tend to be ones that I will provide for you. They're not ones that you need to know. And then importantly, we have chemical conversions. We are going to learn these as we go throughout the course. We're not going to introduce them yet, but we're going to introduce their concept and understand that we'll be able to use them to help us solve chemical problems. So they're things like molecular weight, coefficients from balanced chemical equations, talking about things like concentration, which we measure in molarity, and chemical properties like enthalpy, and so many more. Unit conversion is going to be a skill that we will see throughout the entirety of this course, so it's a really important skill to master early. So again, to highlight these kinds of different conversions that you'll need to use, prefix conversions. So this is a table that shows the different prefix conversions. These are things that you need to know, okay? These ones that are bolded here. So mega, kilo, and then these ones down here, these smaller ones, deci, centi, milli, micro, nano, and pico. So you want to be able to know those unit conversions. Again, we will practice, we'll have lots of time to practice in class with using these, but these are ones that you need to know. So for example, centi is 1/100th. And sometimes you can have things that just help you remember that. Oh, I remember a centimeter is 1/100th of a meter. A kilometer, that's a big thing, right? That's going to be 1,000 times a meter. So we're always going to have our base unit that we refer to, and sometimes we're going to have these things that we know from our everyday world that can help us remember what these prefixes are. English to metric conversions, again, these are going to most often just be given to you. I'm not going to expect that you know how to convert inches to centimeters or pounds to kilograms. You'll be given those values. You just need to know how and when to use them. And don't worry about any of the content on this slide. This is just kind of to show you that by the end of chapter 3, these are all kinds of chemical unit conversions that we will not only know about, but know how to use. So don't worry about this slide yet, but these are things that are yet to learn. So one of the things that I will always do with the problems that we work through is create what I call a roadmap. So that's going to be starting out with information that we know, units of a given quantity in the problem, and we're going to use stepping stones to literally connect it to where we want to go. Okay, so in this case, and with a simple example problem that I'm going to talk about here, we want to know what's the mass of 1 case of NyQuil medication. Okay, so we're going to talk about the fact that we know we've got 1 case, and I'll highlight that those are some other pieces of information that we do know. So we know that we start with 1 case, and we want to know the mass in grams. So how do we connect these two pieces? What are the stepping stones that we're going to use? And again, this information is going to be provided in most of the problems that you have. So in this case, and in this example problem, we know that a case contains 12 bottles. So we can say that 1 case is equal to 12 bottles, but we also can say that 1 bottle is equal to 1/12 of a case. And this represents a bridge that allows us to walk between, we know we have 1 case, to how many bottles we have. Another piece of information that was given to us in a problem, we know that 1 bottle weighs 247.4 grams. So we know that this can be a walk between bottles and mass in grams. You'll notice here that when we have these relationships, these show us the stepping stone that allows us to walk between those units. We only can take 1 step at a time. We can't jump over 2 or 3 stones. So we need to have these units that bridge and connect together. Okay, so how this works is when you start with something that you know, it's going to have, again, a value, a unit, and sometimes a qualifier. In this case, it's a value with its unit, 1 case. What we want to do when we multiply by units of 1, remember that 1 case is equal to 12 bottles. So 2 things that are equal to each other put over one another, that's equal to 1, which means if I'm multiplying by 1, I'm not changing the amount of NyQuil that I have. I'm just changing the units that I'm talking about it with. So in this case, I start with case. I want those units to go away. So I need to put case in my denominator here so that those units will cancel out. Okay, we'll talk about this in a minute, but when we have these unit conversions, they can be used in either direction, okay, with either unit on the denominator. So in this case, 12 bottles goes in the numerator, 1 case goes in the denominator, and that allows me to cancel these, because if you have something in the numerator and the same thing in the denominator is a unit, they'll cancel. Then when I set up my next unit conversion, now I've walked to bottles. I want bottles to go away, and I want to be left with grams. So I'm going to use this unit conversion to put the 247.4 on top and the 1 bottle on the bottom. And now we keep walking until we take the units that we were given and we end up with the units that we want. And that's basically how unit conversion is going to work. So I want to talk a little bit about the types of quantities that you're going to see in unit conversion problems. So some quantities that you're going to see, especially if they're things that you're given, are going to be what we call single unit quantities, meaning that there's only 1 unit with them. For example, 1.45 grams of medication or 37.5 milliliters of liquid. These aren't a relationship between different units. They are single unit quantities. These are often things that might be measured or determined, but keep in mind they could be used as what we call a reciprocal. So this 1.45 grams of medication could just be used just like that, meaning it's kind of over 1. It's in the numerator. However, you could use it in its reciprocal form. That would be okay, again, depending on what the units of your problem are. And we're going to practice and see lots of examples of how to use things like this. So that's a single unit quantity. A relationship quantity is going to be one that has 2 units as part of it. And again, you might be given these or you might need to know them in order to solve a problem. So for example, density, that's a relationship quantity between mass and volume. So 1.6 grams per milliliter. Another relationship quantity is the one that we used. 1 case is 12 bottles. We can use these relationships what we call right side up, meaning that in this case the 1.6 is in the numerator and the 1's in the denominator, Or in this case, we could have the 12 be in the denominator. But keep in mind, you could use these the other way. Because if these two quantities are equal to one another, so that their relationship is equal to 1, that's the same no matter how we have this. So I could use these same relationships in a flipped orientation, okay? Upside down, if you will. So don't be worried if you have to flip a unit conversion in order to have that be the right orientation to have your units work out. All right, careful with calculations. I'm going to go through a little example here just to highlight the importance of kind of putting things in sort of the right order. So I'm going to create just a new problem here. Let's say you wanted to figure out what's the cost of 1 inch of a Twizzler candy, right? The Twizzler candy bar, the licorice that you get. So here's some information that we know, and I'm already going to set up the unit conversion to work out, but I kind of wanted to highlight what's going on here. So let's say that you know that it's $3.79 for 1 package of Twizzlers. Now, another piece of information that I know is I've counted the number of Twizzlers that are in a package, and so I know that 1 package is going to contain 12 pieces. Now, if I go through and I weigh one of those pieces, I measured one of those pieces, and 1 piece is going to be 8.0 centimeters. And we'll talk about in a little bit why I put that 0.0 there. And I also know I wanted to know it per inch. So I know, because I can look up on a table, that it's 2.54 centimeters is going to be in 1 inch. Now, I want you to go through and try to work through this on your calculator. If I'm talking about this mathematically, I could say 3.79 times 2.54 divided by 12 times 8. That makes sense looking at what I've written down here, right? I could say 3.79 times 2.54 divided by 12 times 8. So I'm going to write that down now. We could say 3.79, and I'm going to just not write my units now for simplicity's sake here. Let me not put parentheses. 3.79 times 2.54 divided by 12 times 8. Go ahead and put that in your calculator and see what you see. My guess is, depending on how your calculator works, you'll get one of 2 answers. Okay? You might get 0.100, I think it's 26, or you might get, 6.4177. Now, clearly, those are 2 very different answers, and it's important that we know which one we want to have. So let me highlight what may have happened here. This is the correct answer, okay? It's about 10 cents per inch of Twizzler. And if we use our logic hat, this should make sense. If we just paid $3.79 for a whole package of Twizzlers, which is a lot of inches of licorice, it shouldn't be that it's $6.4 for 1 inch. So that should set off a few alarm bells in our head. But here's what happens in your calculator. Again, depending on how your calculator works, we really want to have that it's this quantity divided by this quantity. But depending on how your calculator works, you might be actually typing things in. So again, this is the wrong answer, but your calculator might be doing this together and then multiplying that quantity by 8. So we have to make sure that we're comfortable with how our calculators work. And one of the things that I'll highlight for you to do is, if you're not certain, and especially early on, you can always multiply everything in the numerator and get an answer, which in this case would be 9.6266, and then multiply everything in the denominator and get an answer, and that would be 96. Then do that simple division, and that will get you to the correct answer. So again, you might have a calculator that doesn't have problems with that, but in case you do, I wanted to make sure to highlight a way to make sure you always get the right answer. But again, we want to make sure we've got our logic hat on too, because we shouldn't be spending, $3.79 for a package and then doing a calculation that says it's $6.42 for an inch. All right, a couple more things here just to highlight, to wrap up sort of this calculation piece. Units and significant figures, or what we call SFs, are going to be a really important part of getting full credit for a problem. So again, part of arriving at a correct answer is to include the correct units. Most answers that you're going to have should have units with them. There are going to be a few chemical quantities that we'll talk about that are unitless. You might have a ratio between something. You might have a special chemical parameter like an equilibrium constant that doesn't have units with it. Okay, but those are few and far between. Most often you're going to need to have units, and you're going to need to express your answer to the correct number of significant figures, sometimes referred to as significant digits or SFs. As a general rule, your answer is only going to be as significant as your least significant quantity. So again, saying this another way, your answer is going to be limited by the quantity with the least number of significant figures. And the type of math operation that we have here is going to come into play here. I will highlight for any of my assessments, you're always going to get plus or minus one significant figure. So even if you're off by one, say the answer is supposed to have 3 significant figures, if you presented it with 2 or with 4, you'd still get full credit even though it was supposed to have 3 significant figures. So I have a little bit of leeway on that, but you want to make sure that you know how to figure it out. So how do you determine significant figures? There's a little flow chart here. I'm not going to spend a lot of time on this. Basically, any number that's not a 0 counts. Zeros are where things get a little bit difficult and a little bit more challenging. So again, if it's something that's not a 0, it's significant. Okay, so in this example here, we've got the 1 and the 5 and the 5. Those are significant, but zeros are where it gets tough. So if we've got any zeros that are between non-zero digits, those automatically are significant. So for example, this quantity would have 5 significant digits. Okay, if it's a 0 that's not between non-zero digits, this is where it gets a little fuzzy here. Look for decimal points. Is there a decimal point in your quantity? If there is, then we might have something that's significant, right? If there's not a decimal point, then for example, this 0 and 50, not significant, okay? If there's a decimal point, then we need to actually ask where that decimal point is in relationship to those zeros. So for example, if that decimal point is before those digits, so those zeros are at the end, those are significant. This quantity has 3 significant digits, okay? The zeros that appear before it are not significant. We call these leading zeros. So again, this guy has 3 significant digits because those 2 zeros that are in red are significant, but the zeros in the front are not. So we'll have lots of opportunities to practice this, but you want to be able to know how many significant digits you have so you figure out how many you're going to have in your answer. So one of the last pieces I want to kind of work through is understanding how to carry significant figures with different kinds of calculation. So multiplication and division is going to be a different kind of determination for significant figures than addition and subtraction. So I'm going to go through 2 quick examples here just to highlight how this works. Okay, so let's imagine that we're multiplying some numbers together here. Let's say we've got 9.2 centimeters times 6.8 centimeters times 0.3744 centimeters. Now, one of the things I want you to encourage you to do is do not round your answers until the very end of a problem. Keep, probably 4, 5, 6 significant figures until you get all the way to the end. So that's what I'm going to do here. Numerically, I'm going to have 23.4255. My units are going to be centimeters cubed, but let's go through and figure out how many significant figures we're going to have. Well, there's 2 significant figures, 2 significant figures, and then 4 significant figures. My answer can only be as significant as my least significant value that I used in my calculation. So in this case, I have to have 2 significant figures. So the 2 significant figures I'm going to have are right here. I always want to look immediately to the right because I have to see how I might need to round this problem. This is 23.4. So in that case, I'm going to round this. And you'll often see me in problems. I'll write a little curly arrow like that and I'll write SF, meaning that I'm going to round it to 2 significant figures and I'm going to have an answer of 23 centimeters cubed. Okay, so think of it like sort of a weakest link situation. I'm only going to be as strong as my weakest link. So let's talk about addition and subtraction. Let's say that we've got 83.5 milliliters, and we're going to be adding that to 23.28 milliliters. So in this case, it might be helpful if I kind of line these up so we can see where the decimal points lie. So 83.5 milliliters, and I'm going to add that to 23.28 milliliters. And again, go ahead and add this up. I'm not going to round or do anything yet. 107.78 milliliters. So how this works with addition and subtraction is I am only as accurate as the fewest number of digits to the right of my decimal point. So in this case, I need to stop with one digit to the right of my decimal point. Okay, so that's where I'm going to have to round. This is where my significance is going to stop, but I need to look to the right there in order to figure out how to round. Okay, so in this case, I'm going to be rounding to one digit to the right of the decimal point. And so in this case, I'm going to round and it's going to be 107.9 milliliters. Okay, so 107.9 milliliters is going to be the final answer that I'll have for that problem because I'm limited by having only one digit to the right of the decimal place. Okay, so again, I've got a little kind of comment here. In general, don't round to significant figures until the very end of a problem. Keep 4 to 5, even 6 significant digits until you get to the end. That's a classic place where students are going to be off on their final answer because they round too early. So don't round too early. Round once. Wait till the end. Last little piece to highlight is a different way that we can represent either really large or really small numbers, and that's called scientific notation. So you may have heard of this before. It's a way to kind of represent things with a coefficient and then an exponent. And again, this is to deal with quantities that are either very large or very small. So very large quantities are going to have an n that is going to be positive. Very small numbers are going to have an n that's negative. So something that I do need you to know how to do is to put numbers into scientific notation or to recognize what they'd look like if you were to take them out of scientific notation. So again, if this is a skill that you need a little bit more help with, feel free to see me kind of independently, but I'm going to operate under the assumption that people know how to recognize and use numbers in scientific notation. Last thing here to mention is when we talk about exact numbers, some numbers are what we call exact, so there's no uncertainty in associated them. Generally, these are going to be things that are definitional numbers or counting values. So as some examples for things that we did, that one case being 12 bottles, that 12 doesn't kind of play into our significant figures because that's an exact number. Actually, same thing with the 2.54 centimeters being 1 inch. That actually is an exact number, so that won't play into our determination of significant figures. So again, here are just a few more examples of things that are by definition values, and again, counting values. So anything that's an exact number or an exact value, you do not use to limit the number of significant figures that you might have in a calculation. So let's kind of finish this up and finish this initial calculation that we did and make sure that we kind of solve this problem and get things to be in the right number of significant digits. So again, this piece is going to be an exact number because it's a counting number. So we're not going to use that 12 and limit ourselves to 2 significant digits. In reality, we only then have one digit that's going to determine our number of significant figures or one quantity, and that's going to be this quantity right here. There's 4 significant digits in that value, so we're going to want to have 4 significant digits in our answer, which means this is going to be the last significant digit that I'm going to have. The 2, the 9, the 6, and the 8 are all significant, but I need to look one spot to the right to see whether or not I'm going to round that last digit up or I'm going to leave it as it is. In this case, 2968.8 is going to round to 2969. So taking this digit or this value here, this quantity, and kind of rounding it, I'm going to get 2969 grams. And to highlight just with our little Twizzler example, remember I told you it was 8.0 centimeters. That's what I measured my piece of licorice to be. That 8.0 was important because that told me that value had 2 significant digits with it. Okay, so we have to look for those decimal points because that tells us that we know something with greater confidence and accuracy. All right, so I know this was a little bit longer of a skill video, but we're going to spend lots of time in class working through solving these unit conversion problems, an essential skill to mastering so much of what we're going to learn in chemistry.